We're going to be looking at proportional reasoning, and the method we're going to use to solve this question is by using diagrams or concrete materials. The overall expectation is to solve problems involving proportional reasoning, and the specific expectation is to solve for the unknown value in proportions using a variety of methods, in this case, concrete materials. So we'll read through this question right once, and then we'll highlight what's important. The table below shows the cost of water for 3 different customers. They each pay the same cost per liter. Here's our table. Gabriel pays $46 for water at the same rate. Determine the number of liters of water that he purchased. So let's highlight. The table below shows the cost of water for 3 different customers. Okay, we know that. And they each pay the same cost per liter. That's important to us. Here's our table. Here's customer 1, customer 2, and customer 3. Gabriel pays $46 for the water at the same rate they do. Determine the number of liters of water that he purchased. So that's what it's asking us to do. Okay, by concrete materials, what we're going to use is some counters. Okay, so we need some counters to represent some of the relationships. And I'm going to quickly look here. It looks like customer 1 might be a good one to start with. Our amounts are relatively even for the liters. Okay, and we know essentially we need to get a ratio that's going to build up in our cost. Let's get our cost value here. Our cost being $46. Okay, we don't know how many liters that he purchased. Our 10,000, this is what we're increasing by, 10,000 every time. 10,000. That's a good value to maybe use for this question. So each of our counters we're going to use is going to be 10,000 in our liters. Okay, so let me see if I can get something here. And what we'll use is a snowflake. That's kind of hard to see. Let's use a happy face for liters. Perfect. So each happy face is going to equal 10,000 liters. Okay, so there's our first ratio. We could do a very similar ratio, okay, so this is under liters, with our dollar amounts. The only problem is 920 is kind of an awkward number to work with. It's not that it can't be done, but it can be a little difficult to count with. I could say 1 star equals $9.20. But then as I add stars along, it gets a little difficult. So I'm going to kind of split this up. And what I'm going to do is maybe use 2, 3, or 4 stars to represent another number. Okay, so if I were to put 2 stars in this place, let's say I put an extra star here. Okay, that means I'd have to split 920 into 2. So I'd have to take 920 and divide it by the number 2. 9.2 divided by 2 equals $4.60. Now that is actually a really good value for us. If you notice, I'm going to erase this now. Oops. Let's bring that back. Because it's $4.60 for 2 of them, and the reason $4.60 is really good is because we know that Gabriel needs to get to $46. Right? And I can actually do some quick math. I need this decimal just to move over 1. I know that if I were to just quickly multiply by 10, I would have 46. So if I do tenths of these values, okay, so if each star equals $4.60, I just need 10 stars, okay? And we know that every 10,000 liters is $9.20, so I need 2 stars for every 1 happy face, all right? Because these 2 stars represent that $9.20, and then it goes up to 10,000 liters. And that's what the value is increasing by on our money amount. Our money is increasing by $9.20 each time, okay? So in order to figure this out, okay, and just as a side note, we could have split this number more. We could have maybe did 920 by 4 stars. So I said, sorry, let's clear that. 9.2 divided by 4. And we could have $2.30. But $4.60, like we said, just happens to work out really well for this question because our goal is to get to 46, and we know we just need 10 of these stars in total. So every time we use 2 stars, we need to use another happy face. So I'm going to get these happy faces to build. So I need an extra happy face. Okay, so now up to 4 stars, and I'm going to do the same thing with these guys here. Turn them into different colors. So we have another 2. Okay, so now I have 2, 4, 6. I need another happy face. Okay, we'll kind of put them in the groupings. I'll circle them so you can kind of see what we're doing. Here's one set of 920, another set, and these are our liters. There's 10,000, 20,000, 30,000. And this is essentially where our customers were. Let's keep building these sets, okay? If we were to get another set of stars, 1, 2, we would need another happy face, okay? So we're now at 1, 2, 3, 4, 5, 6, 7, 8 stars, okay? And remember, we know we need to get to 10 to equal the $46 that Gabriel paid, okay? And that gives us 1, 2, 3, 4 times 10,000. That's 40,000 liters. So we need one more set like this. So let's bring out one more. We've got to our 10 stars. We need one more happy face. Each of those happy faces represent 10,000 liters. We know we're now at $46, so I need 1, 2, 3, 4, 5 times 10,000. If you use your calculator, we know that 5 times 10,000, if I just do it down here, 10,000 times the 5 happy faces we have is equal to our $50,000, okay? And just to make sure our stars are right, remember every star, so these were happy faces. Remember, one happy face was equal to 10,000. Each of our stars, let's see if I can do this. I don't know if I do that. There we go. Each of our stars was $4.60. We know that times 10, because we had a 2-to-1 ratio. That's what it was looking right here. We had 2 stars for every 1 happy face, okay? We know that that equaled our $46. So that works out perfectly. So it turns out that Gabriel purchased 50,000 liters when we used our concrete materials to measure this relationship. If you'd like to see other ways to solve this question, check out our other playlist on proportional reasoning.